Good afternoon and welcome back. We are proud to present Ananda Rajagopal with Gigamon. Please give him a warm welcome.
Welcome, everybody. So in the next 15 minutes, we'll talk about gaining application and security insights in AWS. If you have not heard about Gigamon, we are a market leader in the space of network visibility that focuses exclusively on providing visibility using network traffic into both on-premises and cloud. Specifically to AWS, we are part of the partner network, an advanced technology partner, and as of this morning, just an hour back, we also announced that we've achieved the network competency status that AWS announced earlier today. So a couple of things first. One of the reasons why we're talking about this topic is because the cloud operates on a shared responsibility model, which means that the responsibility for security of the cloud is done by AWS, whereas the security of the data in the cloud is obviously your responsibility as a customer. And that naturally raises the question in terms of how do you get visibility into all the data that's traversing your VPCs. This includes security of data, of applications. How do you make sure that data classification, internal compliance, organizational compliance, industry regulatory compliance is met? The priorities today when we speak to cloud operations teams and security operations teams are clearly in terms of lifting and shifting more mission-critical workloads to AWS. There are a lot of digitalization initiatives that are going on. And oftentimes, in the process, they want to apply the compliance controls. They want to detect and respond to anomalies, understand the current state of infrastructure versus what the expected state is, and any anomalies or deviations from that need to be flagged. So when we speak to customers, these are very common comments that we see from them. We've anonymized them. However, the actual statements are exactly what these customers are saying, that they're spending more time, more money, and resources in deploying and managing security tools on premises and in the public cloud, and they're looking for consistent visibility across both of them. The other one that we see very commonly is when we go talk to a security team, a security operations team in a large enterprise, and ask them a very simple question. Your organization is running a lot of workloads. How do you have visibility into everything that's going on in the enterprise? Because the domain of your enterprise no longer stops at on-premises, it also extends to the cloud. And we usually get a blank stare in response to that and say, tell me more. We did a survey in July of this year using Vance and Bone, and 91% of the survey respondents said that they want to approach cloud network security very similar to on-prem security ops. So there is clearly a need for this out in the market there. For those of you who were here at AWS reInvent last year, you would recall that we introduced the industry's first visibility solution for AWS last year. And the summary of this is it provides a consistent way to access network traffic, because network traffic is the best way to understand the transactions which are happening in the cloud. It also provides a consistent way to distribute traffic to multiple tools. And this becomes especially important in security use cases because there isn't one Uber tool that you have in security. You have a best-of-breed security stack. And in order to detect and respond to any changes or anomalies that are found, you do have a need to distribute traffic to multiple tools without overloading the workload in the process. Many times, the kind of traffic that each specific operational tool needs to see is also different. So there's a need for customization. And also, because cloud is inherently based on an elastic model, as your workload scale, you also want to make sure that the ability for your solutions, your operational tools to scale automatically also exists. So that is basically what we introduced last year. And it's a kind of a summary of how our solution works. So the core here is what you see highlighted called the visibility tier, where essentially the integrations with Amazon APIs, with CloudWatch, and the orchestration of the whole solution is done by the component that you see there called the GigaView FM. And the block in the center that you see called the V series is what does the data manipulation to select the traffic of interest, optimize it, and then deliver that to the tools of interest. Many security teams today are faced with the following challenges. They want to manage multiple VPCs across the entire enterprise and have the need for centralized visibility. At the same time, they can't replicate the tools. It just becomes way too expensive. It just doesn't scale and is simply impractical. Don't forget that if you want to reuse your tools that you've already invested in the on-premises world, then there's a transfer cost when network traffic is sent to a centralized tool VPC or on-prem, and that can become pretty significant if you're not paying attention to that. And last but not the least, they also want to detect early signs of a security incident if and when that happens. So along with the capabilities that we introduced last year, today we're also pleased to announce the capability to generate NetFlow records in AWS natively. And this provides an excellent way to summarize the information of all the flows that are actually happening in AWS. This includes understanding the source and destination of the traffic flows, the protocol, the specific port that was being used, the class of service, and other such details, including instrumentation in terms of packets and bytes per flow. The records themselves can be generated in either v5/v9 format or also in the newer IPFix format. And one of the benefits here is that because there's such a large ecosystem of tools that readily understands NetFlow records, this is pretty much plug and play. Any SIEM, any tool that understands NetFlow, you can effectively point the NetFlow records generated by this platform towards that specific tool. This is not an exclusive either or. You can actually do the NetFlow record generation along with the packet capture as well. So what you see in the bottom there is an example where a certain set of tools may be interested in capturing the entire packets, whereas some other tools may be interested in just in getting the NetFlow records. And it's whatever is the right one for that specific tool would be generated by the platform here. One of the big benefits is the dramatic reduction in terms of the data that's transferred. So many times you also want to find anomalies over time, deviations in terms of patterns. And in order to understand what the deviation is, you first need to know what the norm is. So understanding that norm over a long period of time, let's say about 2 months or 3 months or several weeks, for example, would require a fair amount of data to be consumed, and flow records are a pretty good way of doing that. We have calculated that there's up to a 99% reduction in data transferred when compared to full packet capture. And so a good way to use this would be to use it as a 1-2 punch. So when you want to do any kind of coarse analysis, use flow records. When you want to do detailed analysis, you supplement that with full packet data or wire data. So the NetFlow records themselves provide summarized information into the traffic source, destination, congestion causes, class of service, and using this in combination with packet data, you could help accelerate the migration of your mission-critical workloads to AWS. The second key capability that we are announcing today is the introduction of a capability called header transformation. And this is interesting, especially when you've got a lot of business units that are going off on their own and spinning up workloads, spinning up their own VPCs. They often have overlapping IP addresses. And then when the central IT team or security operations team comes into play, they want to make sure that there's a consistent way to do that. When mergers happen, exactly the same problem happens. So the question is, how do you make sure that the IP address that is there in the left VPC, that says 10.0.1.0, is actually considered to be different than the VPC on the right that represents a different business unit, right? So there has to be a way to disambiguate the two, even though the traffic from both of them are being sent to the same centralized monitoring VPC. So the problem statement here that you see on the left is the application port numbers, IP MAC addresses may end up being exposed to the tools, and that may not, again, be something that is desired. So imagine that data is being sent to a third-party analytics firm for analysis of it, and you may not want to actually expose the intricacies in terms of the IP addresses or some of the other header information, just the actual data that needs to be analyzed. And then, of course, the overlapping subnets as well. So the solution for this that we're introducing is the ability to tag the data that's coming out of each of those VPCs. You could tag them with various kinds of headers. It could be as simple as a VLAN, can be even more sophisticated, such as a tunnel ID or a VXLAN or a GRE tunnel ID, etc. You could also set the specific priority in the DHCP bits before being sent over to the centralized VPC. So the key capabilities here are the ability to modify and mask headers, super important for compliance and security purposes, and also provide visibility or obtain visibility for overlapping VPC subnets by adding the tunnel IDs that I mentioned before. And because this could be traversing the same network as your production traffic, it might be required to also prioritize your visibility traffic for backhaul accordingly, which is where setting the appropriate priority and diff serve code points becomes important. So I'll just do a quick demo here in terms of the actual Okay, so what you see going on here is the desire to send the traffic to two different tools, one to RSA NetWitness and another to Splunk. The process starts by basically setting the necessary policies. Here we are specifically looking at HTTPS traffic. The goal is to capture all the HTTPS traffic and send that to an RSA NetWitness tool. There's also a Splunk NetFlow collector that's been set up. And in the second case, we just want to capture the NetFlow records and send that to the Splunk collector. All the full packets are being sent to the RSA NetWitness. Notice that both of these can be done concurrently. As you saw there, it's a fairly easy click and drop interface, although application programmer interfaces are also available to automate this at large scale. And what this shows is the traffic being received both by the RSA NetWitness as well as by Splunk. Now, there may be situations where perhaps receiving the traffic may become way too much, and you want to kind of throttle it a little more. So let's say you want to optimize the traffic. You could apply one of the traffic intelligence functions, such as sampling, wherein you decide, I'm going to only send a certain sample of traffic to the tool, so that not all the data is actually going to that specific tool. Or the other example is the case of elastic scale, where let's say you want to scale out the application to multiple instances. When you do this, you want to have minimal impact on the actual monitoring session. So what you see here is that as soon as the additional instances get spun up, there is actually nothing that you're doing in terms of the monitoring session itself. You'll see that that went up automatically from 4 to 8 in terms of the number of monitoring sessions that were active. So if you want more details on this, we'll be happy to do a more detailed demo in our booth. So the key takeaways here are NetFlow and IPFix in AWS. While VPC flow logs exist, there are often constraints in terms of what kind of data you can get flow logs from. For example, traffic to a DNS server, for instance, or specific subnets, you can't really get the detailed information there. Whereas with this, you can actually get flow record information without any kind of constraints whatsoever. A dramatic reduction in data. The header transformation is useful when you want to mask certain headers or when you want to disambiguate the traffic from multiple overlapping subnets. So if you need more info, you can talk to our experts in booth number 1505. Feel free to stop over. You can also try a test drive. You can go to gigamon.com/AWS, and there is a free test drive that you could register for and try it out at no cost. We'll set up a sandbox so that you could get to taste some of the capabilities in the process. I'll be around if you have any questions. Thank you for listening.